Like I said earlier, this section 2.7, I believe, optimization divided into two parts. One is the local or relative minimum and maximum. Another is global minimum and maximum, or absolute minimum and maximum. So in our last class, uh, we talk about relative or local minimum and maximum values. And we learn how to find the local local or relative minimum and maximum from the graph as well as from the equation. And in today's class, we'll focus our attention on global, or sometimes called absolute maxima and minima. Okay, so what is absolute minimum and maximum? Let us look at this graph here. Okay, so as you can see clearly, this point right here is one local minimum. This point right here is maximum. Okay, local maximum in that locality, in that neighborhood. This is the maximum point. This is another minimum, local minimum. This is local maximum, and this is local minimum, and this one is the end point, and this function is going on that direction. Now if here what we notice is that if I look at this from this way, okay, this is my, let me just put the graph here. For example, this is my y-axis and this is x-axis. So this is A here. Let us suppose that this point is B, this point is C, this is D, this is E, and this is F, for example. Now, you know the relative minimum and maximum. That's, I think we already discussed that. We are talking about absolute maximum. So for absolute maximum, out of all these points, which one is the real maximum point? As you can see, which occurs at x equals b. Thank you. That is called the global or absolute maximum at x equals b. There is one maximum point, there is another one, and when you compare that, because look at the word global. So we're looking the whole graph at once, okay? The graph as a whole. This is the true maximum at x equals b. In the same way, absolute minimum at x equals, out of this minimum, out of all of these points, then at x equals e, this is the true minimum. When you look at the graph as a whole, that is the true minimum. So therefore, this is called absolute minimum. Now, what it means in terms of, mathematically speaking, what we can say is that this point is f of b. Okay, this point is f of b. So f of b is greater than all other points in the graph. Okay, f of b is greater than all other points in the graph. In the same way, if I want to speak in the language of mathematics, this f of e is actually the smallest, lowest point in the function, which is f of e is less than all the other values of f. So that's how we define global minimum and maximum. Now the question is, if you are given the graph, I think you can tell just by looking at the graph which one is the real maximum, which one is the global maximum, or which one is the global minimum. But life is not that always easy, right? Sometimes they give us a function or equation. And one way to do this is to draw the graph, but drawing graph is not fun in most of the cases. And even if you draw the graph, finding the actual exact value, accurate value is not easy, right? So what we're gonna do is we'll learn some technique to find the global minimum and maximum, even if we are given the function. Now, a couple of things. In order to find the global minimum and maximum, the possible candidate, okay, possible candidates for absolute minimum, maximum, and minimum are, as we can see, critical numbers and endpoints. So these are the candidate, critical numbers and endpoint. Just keep that in mind. So for global maximum or minimum, we always test at these points. Let us look at example 1. So absolute maximum or minimum for closed interval. If you look at this example 6 here, find the absolute maximum and minimum values of the function f of x equals x cubed minus 3x minus 2 over the interval -2 and 3/2. Now this one is closed interval. I trust that you know what is closed interval and what is open interval is. So in high school you learn that. Just in case if you forget, then let me remind you this here. Okay, quick reminder. Suppose if I write, let's say -2 and 3/2, this is closed interval. What it means is if I have a number line here and there is -2 and here is 3/2, what it means is both of these points are included. So this is the graph for that, okay? Both of the endpoints are included. And if it is -2 and 3/2, for example, we call it, this one is closed interval and this one is open interval. What that means is -2 and 3/2. This means everything included, but this -2 and 3/2 both are not included. They are excluded, these points. Endpoints are excluded, and we call it open. Sometimes you may have -2 and 3/2 like this. It is called semi-open or semi-closed. Some people call it semi-open, or some people call it semi-closed, or some people call it half open or half closed, doesn't matter. What it means is, in this case, -2 is not included. -2 is not included, whereas 3/2 is included. So this is the graph for that. Just keep that in mind. Now, there are two cases that we'll focus our attention on. One case is when we are given closed interval. What do we do? Well, as we have said earlier, the possible candidate for global minimum and maximum are critical numbers and endpoints. So first of all, the endpoint is already given. That's a good news. We need to find critical numbers. Okay, and you already know how to find the critical number from our previous class. So first of all, we'll find the derivative, which is 3x squared minus 3. And for critical number, we know that f prime of x equal to 0 or f prime of x is undefined. There is no such number. And here we'll get 3x squared minus 3 equal to 0. And this gives me x equals plus minus 1. So that's the critical number. Now, these are the candidate, okay? So the candidate, the possible candidate for absolute, I simply write ABS for absolute, okay? Absolute minimum, maximum are critical points and endpoints. So that means, let me just write down those. -1, +1 are the critical numbers, and the endpoints are -2 and 3/2. So all we need to do is we need to test those points in the function. Okay, now test the points in the given function. So let me just copy the function as it is, which is x³ minus 3x minus 2. Now let me plug in this value, -1, which means -1³ minus 3 times -1 minus 2. I leave it to you, and f of 1 equals 1³ minus 3 times 1 minus 2 equal to 0. And f of -2 equals -2³ minus 3 times -2 minus 2 equals not 0, sorry. You can calculate that, whatever is that. So f of 3/2 equals 3/2³ minus 3 times 3/2 minus 2. And if you work it out, then you will find that f of -1 is 0, I think. Yeah, and then f of 1 is -4. F of -2 is also -4, and f of 3/2 is -25/8. Now all you need to do is compare which one is the maximum here and which one is the minimum. So we have 0, -4, and -25/8. So maximum value equals, it's absolute, by the way, absolute maximum value equals -4 at x equals, no, maximum value is 0. Okay, maximum value equal to 0 at x equals -1, and absolute minimum value equals, as you can see clearly, -4 is the minimum, which occurs at x equals 1 and -2. That's it. That's how we calculate if we are given a closed interval. Okay, case 2. Now another situation arises when we are not given the endpoint. Okay, we are not given interval, or we are not given endpoints, and we have only one critical points, for example. Okay, so for example 7, find the absolute maximum and minimum values of the function f of x equals 4x minus x squared. So how we do here is, again, the candidate is critical number and endpoints. Because endpoint is not there, then the candidate is only the critical points. So we need to find the critical point here. So first of all, let us calculate the derivative, which is 4 minus 2x. And for critical points, f prime of x equal to 0, or f prime of x undefined, no such number. So the derivative is 4 minus 2x equals 0, and this gives me x equals 2. Okay, if you have only one critical numbers, then you can use, we know that this is either minimum or maximum, but we don't know for sure whether it's minimum or maximum. So we need to test. Okay, so if you have only one critical number, you can use either the second derivative test or first derivative test, which both of these tests we have learned in our last class. And we noticed from our last class that second derivative actually is easier and it takes less time. Okay, it's less time consuming compared to a first derivative test. So here, to check whether x equals to 2 is absolute minimum or maximum, we use second derivative test. Okay, second derivative test. You can use first derivative test if you like. If you like. Okay, no problem. We need to test whether it's maximum or minimum. So for second derivative test, let us calculate second derivative first. We have second derivative, which is -2. Right? So second derivative -2, which is less than 0. And we know that from our last class, we discussed, we had a, quite a long discussion in our last class. So this is concave down, which means the shape of the graph is like this. If it is concave down and the shape of the graph is like this, then it has maximum there. Okay, so we already know that x equals 2 gives us the maximum. I mean, the global maximum occurs at that point. So absolute maximum at x equals 2 and the absolute maximum value equals f of 2 equals, now let us substitute this value in the original function, which is 4 times 2 minus 2 squared, and that's gonna give me 4. That's it. Okay guys, now if you don't have any questions on this example 7, and if you know how to do these kind of questions, then example 8 is very similar, and I want you to try this example 8 on your own just for fun. Okay, in example 8 you need to find the absolute maximum and minimum values of the given function. Okay, so what is given here is given f of x equals 5x plus 35x power -1. I want you to find the derivative. 5 minus 35x -2. So try this by yourself. I'll be doing here, but yeah, try yourself without looking here. Okay. So critical number f prime of x equal to 0 or f prime of x undefined. So this side 5x square minus 35 equal to 0. This side the bottom part equal to 0. So this gives me x equal to 0, and this gives me x square minus 7 equal to 0, which is x equals plus minus square root 7. All right, so the critical numbers or points x equals okay, so the critical numbers are x equal to just square root 7 only, because -7, look at the interval, look at the domain. So the domain is 0 to infinity. That means no negative number, and 0 is also not included because of the open interval. Okay, so therefore the only critical point is x equals square root 7. When we have only one critical points, then you can use either the first derivative test or second derivative test to find the minimum, absolute minimum and maximum. So let us try that now. Okay, so to check whether x equals root 7 gives absolute minimum or maximum, we use you can use first derivative, but like I said earlier, second derivative makes, it's less time consuming, and we're going to do that. Okay, we use second derivative test, but if you like, you can use the first derivative test also, no problem. Now second derivative means, let me just copy, we have the first derivative, let me just copy that, which is 5 minus 35 x power negative 2. That is my first derivative. So second derivative is going to be, I can do this here, the second derivative is going to be, this is 0, that will be negative, or negative positive, so I'll get 70 x power negative 3, which gives me 70 over x cubed. That is my second derivative. Now when the critical point, when x is square root 7, that is the critical point. When x is root 7, then your second derivative root 7 is going to be 70 over square root 7 cube. Clearly this is positive, and we know that the second derivative actually tells us the shape of the graph, whether it's concave up or down. So here in this case, we notice that this is concave up, because the second derivative positive means concave up, which means the shape of the graph will be like this. So if this is the case, then we'll have minimum value. Okay, so absolute minimum is absolute minimum equals okay, absolute minimum, we don't know. Absolute minimum occurs at x equals square root 7, and absolute minimum value, you just plug in the function, equals f of square root 7. So let me plug in this in the original equation. Our original equation is 5x means square root 7 plus 35 over square root 7, which means if I simplify it, it looks a little ugly, then let us simplify it. Root 7 plus this is 5 times root 7 times root 7 and over root 7. So this cancel out. So we got 10 square root 7. That is our maximum, minimum value. So that's it about global or absolute minimum and maximum value.